Hello, thanks everyone for coming to this talk. From large language models, we're going to go to tiny systems running machine learning. Typically, you could say inference part of machine learning on small microcontrollers. And I think I bought a little one and a sticker. So yeah, talking about systems like this. This is like a $20 device, complete device that you can run anything you want. Has like the power of a Pentium 1 chip or so. And if you were around in the Amiga days and so on, it's a very powerful system. You can do a lot with it. So let's see some of it. I come from a company called Sound Sensing. We monitor ventilation systems. So in buildings like this, the operators of this building would be our typical customer, and we use sensors and machine learning to monitor that equipment to make sure that the building continues to work. And if it doesn't work, then they will be notified automatically. And we have a lot of customers around in Norway, and a few in Sweden. So for us, this kind of machine learning is about being able to extract useful things directly on the sensor and then send that small piece of data onto the cloud so we can kind of act on it. We'll talk about other applications mostly today. So the goal of this presentation is that you, as a software developer, can build some sort of IoT, Internet of Things, sensor on a microcontroller using MicroPython, and including not just like basic sensors, but also including some on-edge machine learning using a library called emlearn MicroPython, which I maintain. So Python on a microcontroller. Who here has programmed in Python before, like in any environment and so on? That's basically everyone. It's very popular in a lot of domains these days, especially around machine learning, of course. But you might not have programmed it on such a small chip like this. But the cool thing is that you can. So all your existing skills will now transfer in this new domain. What is a microcontroller? Who here knows what a microcontroller is or has worked with one? That's quite a lot, but not all. So a microcontroller is like a modern microcontroller, at least. It's a complete programmable system on chip. And in this image, it's actually the one with the label 1 there, or actually the microcontroller is inside that chip again. And a modern one is actually quite powerful. Like these used to be very limited, but now you get like 32-bit CPU running at several hundred megahertz, several megabytes of RAM, which is like was almost unheard of 10, 15 years ago. And they have Wi-Fi, Bluetooth, USB-C, etc. So it's actually like it's becoming like a small, computer from the early 90s. But still, of course, it's nothing like your laptop. It's nothing like your smartphone. We're talking 1,000 times less resources than that. And you might want to run power, in which case we're talking even less. You might want to run at like 1,000,000th of the power that your smartphone uses. But they're very accessible now because they're powerful, they're cheap, and you don't have to know a lot of electronics to get started, because you can also get complete devices. All these are devices that are complete, including sensors, and maybe like there's displays on some of them, or like a full smartwatch. Or how smart it is depends on the software that you put into it. So you can basically get started with that. These will all run Python directly. And that will be from $20 to $50. And this is, if you're new to electronics, this is probably where I would start. And then you can go deeper if you want. Installing MicroPython, so it's a own implementation of Python. It's not the same Python that you're used to, but it does implement the same language. It is mostly compatible. There are some limitations. You will find them documented online. But you basically download from the website, the MicroPython website. You download a firmware build for your device, and then you can install the tools, at least for ECP32 from pip. And you run a couple of commands to flash that firmware onto your device. And then that's connected then over USB typically. And now you can use this MP remote tool, which talks over the USB serial to your device. And you have a Python prompt. So you're up and running. You can do whatever you would like there, you can start. And there are some IDEs that are specialized in MicroPython, and there's some add-ons to existing IDEs that we use, what you can use if you want. But the basics is just it's flash it, you have a REPL, and you're off to the races. You can start programming. As a simple example, I'll show just like how you would do a temperature sensor or a type of sensor where the phenomena of interest, like temperature, doesn't change very often. We could do this like every minute, might be okay, maybe even every 10 minutes might be okay to say track the temperature of this room or in your home or in your beer brewing process or whatever you're interested in. You could use like many options for temperature sensors. This example uses this little chip here because it has a temperature sensor already. Actually, it's inside the surround, which is special. So it's not the greatest if you want to measure like a fluid or something. It's inside plastic, but it will work. So this is the complete code for a MicroPython-based sensor that will run on this one to read the sensor data in a loop. So that is here. There's an accessor property that has the data and send that data over MQTT, which is a common protocol for IoT systems, which can then be like, you can store it in a database or there's dashboards that will automatically show it for you, etc. And it uses async, which you might be familiar with Python, so it's actually like a rather high-level way of dealing with network, concurrency, this kind of stuff. It's really supported on MicroPython. It's super cool. It's not only a high-level language, but also in terms of the way that you would write Python. It's quite high level. And in this loop, you just go continuously, and we sleep. So here is a fixed sleep, but there's also ways of telling this device to like actually power down, go to a lower power mode. There's both what's called light sleep and what's called deep sleep. That will help you conserve power. So simple things are really simple in this program environment. So it's very productive for just like, oh, I have this thing. It would be really cool if I could do X. And like put a bit of stuff together, and then write a bit of Python code, and you're probably going to get that. So, but in this case, we're using two libraries actually, and we never install any libraries on our device. How does that work? And MicroPython actually has a package manager, which can run directly on your device. So that's what you use to with Python. You expect to just be able to, pip install something. And in this case, you can't pip install it, but you can make install it. So you can do that with the MP remote tool, like from your command line. But for example, if you would use Viper IDE, it's a fully browser-based IDE, so you don't need to install any tools on your machine at all. It also works on Android. For example, in an educational setting, it's super nice to just have kids plug together and open this and they're running. That actually also allows to install packages. So you can just paste the URL, for example, to Git repo that has the right metadata for a MicroPython package, and like a couple of seconds later, in your device has that package built in. So that's really powerful because now it's not just a high-level API, but also a full package management system. And there's a decent ecosystem for MicroPython. So those are the simple things. Now let's go a bit further and see what can we try to push it a bit. What can we actually do with these devices? Is it just a toy, or can we go a bit more serious? So this is like a range of tasks. We're focusing on sensor data here. That's what I work with most, and what these kind of devices are mostly interesting for, like to sense some physical phenomena and do something with that, or act on something. So if you have a smartwatch, 15 watch, and so on, that's usually using an accelerometer, maybe 100 hertz sampling rate. That's quite easily to do in just pure Python. You don't need to do a lot. If you want to go to audio or image or video, you will need to use a little bit of C modules combined with your Python. But the great thing is that MicroPython has excellent support for C modules. So you're not limited to what you can do with Python. You can add in C modules and really extend. If you do a lot of C modules, you can do you're basically limited by the hardware, not really the language. So you can do very intense tasks that you wouldn't think are possible in Python on these small devices. And then there are all examples of this in the emlearn MicroPython library. So we will cover a little bit on. So a sound sensor, for example, there's like, to measure sound properly, there's a few calculations that you should do. You need to kind of do some filtering to approximate how the ear experiences sound, and you need to, you know, calculate energy over a little bit longer time. Just illustrated here. This is one of the examples. There's the emlearn MicroPython, and this here is like the main function. A lot of the all the calculations are done by this sound level meter class, which is provided as a standard thing. But there's like basically if you use there's a one-click install to get that running on your device. And this highlights that in MicroPython you have a module called machine, and that is like a representation of your device or your physical hardware and the peripherals that it has. So and that will be where you can access sensors. So in this case, the microphone we're using is a digital microphone, which is an I2S protocol. So that's where we import that. So that's also where you would, I don't know, if you would control some LEDs, it would be through there, or if you would read some inputs, read some outputs, it will be through that machine module. And then, yeah, so this is just an example of how to set that up. And I haven't shown the code, but we also do render display, and there's a nice little library called MicroPython Nano GUI that allows you to, you know, make small user interfaces that you can show on a device. So that's also quite neat. In the processing side, like in order to make this work, I tried, like always when you develop with MicroPython, it's recommended to try to just do it in Python in a simple way. If it's not fast enough, then consider there's a couple tools. There's it's not shown here. There's some annotations that will just in time compile your functions. MicroPython.native and MicroPython.viper. Those you will find documented online, and they can really like help. They can give you like a 4 to maybe 10x speed up, but sometimes even more. In this case, I tried a pure Python implementation of a filter for approximating the hearing response, and it took over 1 second per 128 milliseconds. So it's like 9 times as much time as you have until you need to do the next thing. So that doesn't work. I couldn't get that below the limit with pure Python. But then that's why we have these C modules. So emlearn MicroPython is a set collection of these C modules, and we provide infinite response filters, so you can, you just, as an application writer, you're just calling this, importing this module and calling these functions, and it happens in C under the hood. As is typical for, say, Pandas, NumPy, TensorFlow, PyTorch, etc. It's also often, C or C++ under the hood. So when you do this, you're running at 20% CPU. So now you have even time to go to sleep, save power, or update the display, or do all the other things that or send to the network and so on. So with a little bit of this, you can do then audio processing, which is cool. And these C modules are relatively simple. This here is a complete module. It just computes the tutorial. It's an example from the official documentation. This shows the structure. You have some C code. You could include some existing C code if you find some online that you have, or you write it yourself. And you typically do a little wrapper function, which is like your binding to Python land. And then you declare the Python module, and you, for example, registers. This will say like, okay, there's a module. I don't remember what the name of the module is. But on that module, there is a dot factorial property which points to this function. And so when you call module dot factorial in Python, this C code will be called, and you can return results, and that's what happens. So it's if you've written a little bit of C or something similar like Python or so on, you can do this with some help from the examples. So it's a very powerful tool. And then these kind of modules can be distributed in 2 ways. And this is something you can either have what's called an external C module, then Your C module is built together with the firmware build. So before we flashed our device, that's all built into one package, and you flash it onto the device. That's like all the existing functionality, like the machine module and so on. It's implemented the same way. So that really has excellent support. But you need to do a build, you need to have the build tools and so on. So what's really cool is MicroPython also allows you to have these modules distributed as a installable file at runtime. So there's a .mpy file format. It's a little bit trickier to, there's some limitations in what you can do and not, but basically you can build such modules, and now your users can install them at runtime. For example, using this MP remote tool. So you can just install, and then a .mpy file actually has C code. So you get that same experience. You can just install things, even though they're implemented in C and so on. And that's really unique as far as I know in the embedded world. So, and it's being improved a lot this support lately. So here's another example what you could do. Middle is kind of activity tracker. For example, there's some tools there in the repo to record data set. Because what's cool about this kind of space of working in is we're talking about small systems, yes, but also you can do quite a lot with small amounts of data. So if you have some idea, you want to detect some phenomena, track like that you're doing your exercise enough, for example, you can collect the data in like a couple of hours. You can collect enough data to train them. So you can work a lot with small data, and you can just build niche solutions for yourself. And yeah, this. So that's using Python to do the calculations, and you stay on standard scikit-learn to train. So like on the machine, on your PC, you're going to train the model using a standard scikit-learn pipeline, or we also support some Keras tools. And then you can save that to a file, load it onto the microcontroller, and have an efficient pipeline. And yeah, and the emlearn also has a C library. So if you are familiar with C and you don't want this Python thing on your device for whatever reason, then you can just use the C bindings directly. Works pretty much in the same way. I will summarize quickly, so we have some time for questions. So conclusions is that modern microcontrollers are very accessible. You can run Python, MicroPython. This ESP32 is a very good place to start. You can start with Wi-Fi ID. You don't need to install much at all. It's a very productive environment for sensor-type devices. You get the familiarity of Python and the ease of use. And you have this MIP package manager where you can install packages from the internet, and including C modules, and also connectivity like Wi-Fi and Bluetooth. And using this combination of Python and C modules, you can implement advanced processing of sensor data, such as accelerometer, audio, images, radar, etc. And yeah, then emlearn MicroPython provides a standard set of DSP and machine learning libraries that you can just plug in. So you don't have to deal with that C stuff, you can just call it machine code. And these are some of the modules we provide. And again, a few talks that go a bit more into detail. So thank you so much. We can have some questions.
Now it is on. Any questions?
Thank you, and thanks for a great talk. So maybe you can mention a little bit in terms of the, let's say, the architectural decisions in terms of doing this in MicroPython as compared to, let's say, TF-Lite or more of a runtime-based kind of architecture.
Yeah, you're thinking specifically on the machine learning side of things, or more general firmware?
No, so more.
Yeah. So TF-Lite Micro is a very established tool for this machine learning on devices. It's like a C++ code base and a runtime, so it supports very flexible structure of the neural networks. It depends on your task. So like, we have support for a standard convolutional neural network, but if you need to do something more complex, we have maybe a custom architecture, etc. Or you have a model that you found online and you don't want to train it again, but it seems that TF-Lite can support it. That's very attractive to do that. If you're doing something for your specific task, where you're going to train a model anyway, and there's no reason to do anything very special, then this is great and I would say much more accessible, much easier to get started. So yeah, those are like some trade-offs. Also sometimes, like if you can run MicroPython, you can probably, C++ will probably not be a problem, but you still have a lot of vendor SDKs that are like, oh, what is this C++ thing? That's some newfangled stuff that we don't support. Good luck. So like being plain C can be a benefit sometimes, and that's like emlearn is C99. That's modern by embedded standards.
All right. Thank you.
Anyone else?
About compatibility, MicroPython compared to regular CPython and the various CPython versions 2.
Yes, you're thinking about as a,
3.14.
you're thinking as a application writer, as I'm writing Python.
Will I notice?
Yes, yes. So one thing that is huge is that the C API is completely incompatible. So that means anything that is native code from CPython land will not work. No NumPy, no pandas, no. So that's big. On the language side, MicroPython is like Python 3.4 plus. So, and it really depends. If you're writing like, you use the latest features in everything, on Python you're going to hit quite a lot of small snags. Just in terms of the style has developed a little bit. There's some niceties that you can do. If you're, if you learn Python around Python 3, 3.6 or something like that, and you're kind of still, that's your style, you might not face any things. So it's, I would say, it depends a bit on style. And if you're willing to adapt, what's very feasible is to have a code base which runs on both. So as long as you kind of do it MicroPython first. So you write it there, and then it will be like, I've never seen something that runs on MicroPython that does not work in CPython. And that's typically how you go about it, because you not just language, but you also have device constraints. Like, there's many things that could work in terms of syntax and semantics, but that will just allocate tens of megabytes of RAM, etc. And that's not going to work on your device, not because of Python, but because your device has maybe 1 megabyte of RAM. So if you write for MicroPython, you can, for example, test it on CPython. And I do a lot to use PyTest on CPython and test my MicroPython code as well. That's super nice to use Hypothesis, like really modern testing tools. Much better than what's typical for embedded. So yeah, it's very productive as long as you take a little bit care about the component, or like have some strategy about it.
More questions? No? I have a question.
Yes.
When you flash the firmware, the MicroPython firmware, does that typically come from the vendor, or are there any community efforts in porting? How easy is it to port to a new platform?
Yes, so there is, like with all embedded stuff, there's a bunch of vendor things with various degree of support and maturity. So I would say, as long as you can, use it directly from, use the mainline version from micropython.org. You go to downloads there, and you will see like all the boards and stuff to support it. And because MicroPython is relatively flexible in terms that you can do things at runtime. For example, for ESP32, there's like one firmware which will go on basically any board. So you don't need to be, it doesn't have to be for this board. And you can still access all the peripherals and so on. And things are moving more in that direction. So you can have this kind of universal, same as when you install Linux, you don't install Linux for this ThinkPad, you install a General 1, and you just go from there. So I would go for mainline first. When you do go for, there are some vendors that are pretty good, like Pimoroni, for example, are really good at supporting their stuff. SparkFun is pretty good at supporting their things. And then there are some vendors that don't really give a shit about support. They will release, they will say, oh, this thing supports MicroPython, and then you go download and it's like, oh, that's a 5-year-old thing. And it will never be updated, and it's forked, and it's matched, and they don't even publish the source code for that. And so yeah, go mainline if you can. But the porting is well, I guess it depends on your standard. If you're a hobbyist and you've never done it before, it will be painful. If you are an embedded software developer that has supported things before, it will be quite well. It's like a very clean code base. You can also, for example, use MicroPython with Zephyr. So Zephyr is your hardware abstraction layer, and that has then like, I don't know how much hardware they support now. It's like in the thousands of devices and so on. So if you do a professional project, I would maybe consider going there, because then yeah, you can mix and match. And Zephyr is like an even better hardware abstraction layer. But you can also have custom ports for MicroPython.
All right, thanks.
Well, two phones, one for the speaker and one for the organizer. Will you make the slides available? And if so, will they be on the website?
Yes, the slides are available. I did put my link to the slides in the system. I don't know how that looks, how it's accessible to them.
I will copy it from the system and then upload everything.
Yes.
Everything we get, we will upload.
Yeah. And if you're interested in this general topic, on my GitHub, Jonnor, Jonnor, you will find a project called Embedded Machine Learning, Embedded ML. It's like a lot about this topic in general, like even like broader. There's some info about TF-Lite there, and I try to collect resources. Very interesting.
So your GitHub is Jonnor, but your email is Jonnor.
Yeah. Someone took it and unfortunately. And I think you'll find a link to the project from there. Yeah.
All right. Thank you very much.
Thank you so much.